Right. Scientific notation is something that is necessary because sometimes we will deal with numbers as big as something like 10 to the 28th. All right, when you get introduced to Avogadro's number, it's times 10 to the 23rd. All right, but there's also for significant figures, this is the appropriate way to write something that has several insignificant digits. Right? So when you have multiple zeros that you can't count as a significant digit, it is more appropriate to write it with scientific notation instead of including those zeros. So, scientific notation, there's two forms. There's the positive form, which is on this slide, right, where you're going to have some number, x, times 10 to the power of some other number, n, where n is a positive number. All right, so right now we're going to deal with n being positive. What that means is that x is being multiplied by 10 n number of times. Okay, so if it's 10 to the second, it's times 10 times 10. If it's 10 to the third, it's times 10 times 10 times 10. Okay, so when n is positive, it can also tell you how many additional spaces you need to the left of the decimal. All right, so you think about decimal, left is this side, all right, in addition to the x, meaning that the x is not included, all right, in your n number. All right, so for positive scientific notation, you don't include the x in your count. So this is that if you have 1 times 10 to the second, that's the same thing as saying 1 times 10 times 10, or 100. All right, if you think about our decimal being here, and 2 means that there needs to be 2 spaces between our x. That's what those 2 zeros are. Okay? You can also have examples like this, like say 1.2 times 10 to the second. All right? In this case, because there's already something to the side of the decimal, all right, you do include the 0.2 in your count. So that would be 120, because it's like 1.2 times 10 times 10. Okay, so x is only ignored if it's in front of the decimal when it's positive. We'll do some more examples, so hopefully this sinks in. All right, x times, this is our negative n numbers. All right, so if it's times 10 to the negative something, negative 2, negative 3, all right, that means that your x number is being divided by 10 that number of times. All right, so if it's x times 10 to the negative 2, it's x divided by 10 divided by 10. Okay, or you can also think about it as like x divided by 100, because that's what 10 times 10 is. When we are dealing with a negative exponent, all right, tells you how many places to the right of the decimal you should place x, all right, which means that x is included in the count. At least any x in front of the decimal. Okay, so let's look at a couple examples. All right, 1 times 10 to the negative 2, all right, is like 1 divided by 10 twice, or this, you can also write that as 1 divided by 100, okay, or 0.01. Same idea as before, say it's 1.2 times 10 to the negative 2, all right, that's going to be 0.012, okay? So the x value is really the number in front of the decimal. But again, we'll do more examples so that you get a feeling for this. Let's write these out. 1 times 10 to the 6th. It's positive, so the 1 isn't included in our count, which means it's 1 with 6 zeros after it. Okay, because now there's our decimal point. We need 6 fillers to put 1 in the decimal point 6 places away. All right, 2.4 times 10 to the 6th. All right, so this one, again, the 2 needs 6 fillers between itself and the decimal point. First filler is going to be the 4, and then we've got 1, 2, 3, 4, 5 zeros. Okay, drew my decimal point a little far away. All right. If you notice, these are both times 10 to the 6th. They are both in single-digit millions. All right. So some negative examples. We have 1 times 10 to the negative 7th. All right. So this 0 doesn't count. This is just my place marker 0. All right. And if we want it to be the negative 7th, that means that between the decimal, from the decimal to where we reach 1, there must be 7 places. So that's going to be 1, 2, 3, 4, 5, 6, 7. Okay. So another example, 3.36 times 10 to the negative 7th. Again, we're going to want 7 places after the decimal. And at that 7th place, we write the first 3. Okay. So we're going to 1, 2, 3, 4, 5, 6, 3, 3, 6. All right. So with negative exponents, where you see things start to match is where the first non-zero digit begins. Okay? Let's write some numbers in scientific notation. Right? So to determine how to write a number in scientific notation, the non-zeros matter. Okay? And you only want 1 digit before the decimal. So this first one's easy. We only have 1 non-zero, so it's going to be 1 times 10, and then you need to count how many spaces there is between, since this is all in front of the decimal, count how many spaces there are between your 1 and the decimal point. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So this is 1 times 10 to the 9th. Okay? Now, when you have more than 1 non-zero digit, you keep the first one in front of the decimal, and then all the other ones go after the decimal. All right? And then when you're counting, if it's a positive, the only non-zero digit that you don't count is the first one. Okay? So there's going to be 1, 2, 3, 4 other digits between the 3 and the decimal point. So that's going to be times 10 to the 4th. Okay? Now, when you're dealing with a number less than 1, this is where the negative exponents come in. All right? And the rules are kind of the same. The non-zero digits, 1 non-zero digit and the one, furthest to the left gets recorded. But when it's after the decimal, you do include the 1 in your count, okay? Because we're trying to move it that many decimal places after the decimal. So it's 1, 2, 3, 4, 5. So this is going to be 1 times 10 to the negative 5, all right? Numbers less than 1 are negative scientific exponents, okay? Or scientific notation exponents, sorry. So next one, we're going to write our non-zero digits, okay, 3.12, and then since it's after the decimal, we count to the first non-zero, all right? So it's going to be 3.12 times 10 to the negative 3, okay? So the trick to scientific notation is knowing the minute differences between what you do when you're dealing with a positive exponent and when you're dealing with a negative exponent. The big key thing is with positive exponents, the 1 number in front of the decimal does not count. All right? You count all the digits between that first number and the decimal point to figure out what your exponent is. And then the major difference from that for negative exponents or numbers less than 1 is that you do count that digit that is right in front of the decimal point. Okay, so like the 1 was counted, that's how we got to 5 spaces and -5. The 3 was counted, that's how we got to -3. Okay? So please have notes for class and do the online assignment.